Hello, welcome back. In the previous video, we have seen and understood what is Cosmos DB and what are the different types of APIs that Cosmos DBs provide. And in this demo video, we will understand how to create a Cosmos DB account and inside the account, how to create containers and how to actually use the Cosmos DB. So we will go to the Azure portal and create a Cosmos DB account, and we will do some hands-on in this video. Also, after creating a Azure Cosmos DB account and container, we will see different parameters like throughput, and also there is something called as latency. So these two parameters we can control in Cosmos DB based on our necessity, and there will be cost implication based on that. Let us see that in all these in this demo. So before proceeding, if you're in a learning path about data and haven't subscribed for this channel, please do like and subscribe for this channel, and don't forget to press bell button for instant notifications. Let's get started. So now that we are in Azure portal, so portal.azure.com, so we have already logged into Azure portal, and we can directly search for Cosmos DB here. So I'm just searching for Cosmos DB because I want to create a new Cosmos DB account. So that, because of that, I'm searching this and I'm coming in this Cosmos DB kind of a directory. So if you see here, there is an option to create. So when I say create, actually it is giving the multiple options. So all these options are nothing but a kind of API that we have seen in the previous video. So if you're not seen the previous video, I recommend you to see the previous video in the same playlist. But as you can see here, there are 5 APIs which are definitely used for different use cases. Starting with the SQL core, this is recommended. Why they are telling it as recommended is if you are having a new project that is you are starting a scratch project from a new project from the scratch, right? So in that case, you should use definitely this. So otherwise, like if you are choosing MongoDB, Cassandra, Azure Table, Gremlin, so especially this MongoDB and Cassandra and table storage. So this kind of thing, this kind of APIs you can use when you have already these kind of accounts provisioned in different cloud or on-premise. So in that case, you can use it. Uh, Graph APIs definitely it is for a different use case. You can see in the previous video to learn more about it. But by default, you should always go for SQL, core SQL, which almost serves the purpose of storing the data in a document format. Because Cosmos DB is also a document DB, we call it as. So I'm just going and clicking to create here. As you can see, there are a lot of options. So I'm just choosing the existing resource group I already have. So resource group is basically to logically group the resources. So you might have a project. So you are creating a data factory, you are creating Databricks, you are creating Cosmos DB, storage account. So everything you can dump into one logical group so that you can track them logically, and you can track the costing, you can track the auditing, many things you can track using the resource group. So it is generally for the maintainability and grouping purpose. And coming to the account name, so basically you are not directly creating Cosmos DB here. So you are actually creating the account. So inside account, you will provision the containers and like which we can call it as a like database, and then inside database you can create a containers. So basically like here you are just giving the account name. So that should be unique across the globe. I'm just trying to give the account name here, and then so the location definitely it matters because it is already almost recommended to use the location which is near to your resource, near to your customers or end users, so that the latency will be very less. But in case of Cosmos DB, it might not matter much because it is a globally distributed database, and you can have a geo redundancy kind of settings you can see in the next tab. But yeah, I'm just choosing any one of the location for now. And definitely we have a capacity mode, like if you go for serverless, so in that case if you see all the below option are disabled, right? Serverless is nothing but so you won't you won't manually create it, so everything will be created by Azure and it will be managed by Azure, so you will only pay for that service that you are using, right? But here you are manually creating, that means you are paying for the throughput. Okay, there will be dedicated throughput allocated to you. Whether you use it or not, you have to pay for it. You are committing here particular throughput. This throughput you have to use it. Whether you use it or not, you will be charged based on that. But if you go for serverless, you have a cost saving if you are not using it, right? But most of the production cases will go for a provision throughput, but because production will have like mostly in the cases of production, it will be like a constant throughput or constant requirement of a data latency or data movement will be there. And apply free tier discount. Yeah, I'm just giving it apply now, and limited total throughput. So this is especially for, as I was mentioning, this is one of the performance parameter. So I'm just clicking okay, I mean, I'm just ticking it, so I want to limit it. So, or you can just by default you can limit, you can remove it. And next setting is more about the global distribution. So regarding this global distribution, multi-region rights, so there is a separate video we have made. And there is a link in the description. You can just go through that. I'll definitely not go in detail regarding these details. But geo redundancy, definitely it is duplicates or it creates a multiple copy in different area or different regions for that matter, right? So that you can access the data, read, write the data very fast. But so when you select enable this, there is a multi-region write also. Multi-region write is nothing but so you want to when you actually enable the global redundancy, you are creating the secondary locations where your data will be replicated. But only that will be only for by default that will be only for reads. If you want it for writes also, those secondary regions you want to utilize for write also, then you have to enable this. And please note that there will be definitely a cost consequence associated with whenever you're selecting different things here. So as of now, I'm just keeping it to default, and availability zone is again for the disaster recovery and those kind of scenarios. So I'm just going for the networking. So here, if you are working in an actual production kind of environment, you will be using a public. I mean, mostly you can create a private endpoint where you have a subnet kind of thing and VNet kind of thing created based on the your organization policies or the requirements. This is basically for how do you design your networking inside the organization and how you want to place the Cosmos DB inside the network for security reasons and access reasons. And next option, as of now, yeah, I'm keeping this as a uh, default and backup. So it's again for a backup policy. I'll not go in detail. And next is encryption. So where you can choose your, I mean, by default, Azure will provide the encryption key that is called service managed key. But if you want to use your own key, so you can store that in a key vault and provide that here. So I just choose the default one and I'll click on review. So by now the Cosmos DB account is created. So as you can see, it shows the account is created now, and you can choose any of the platforms basically like to create a container. So container is nothing but it is like a I can mention like a database. I mean, yeah, I'm sorry. Container is inside a database, so we need to create a database, and then inside database you'll have a container. That means container are similar to the tables that we see in a SQL or any kind of database, right? So either you can create it here, like using any of these platforms. So as we have seen in the previous video, so Cosmos provide us different kind of options, programming language options to actually create containers and work with containers and the data inside it. So, but as the demo purpose, we will choose the other way of creating a container using UI. So you should go to the data explorer and you can see here there is a default database already created and there is already one item which is already created inside a container. So let's try to create a new container. So whenever you are trying to create a new container, so it should be in a particular database, right? So here you can see you want to create a new database or use existing one. So for a simpler purpose, I'm just want to use the existing database here, and it is a container ID. So as you can see here, this should be unique for each containers and user ID based on the it is used for REST APIs and all SDKs to access it. So that's the reason it should be unique. So I'm just giving something like this, right? And coming to the partition key. So partition key is important here and it is also mandatory. So why it is mandatory in Cosmos DB is they are enforcing us to create a partition key at least by ID. So you can create a partition key based on the use cases like so how you want to data to be get partitioned, right? So if you want data to be partitioned on the location, if you want to create a partition based on some kind of business areas like sales marketing kind of thing, so you can pretty much do that. So that depends on your analysis what is the best partition key, but as of now I'm just keeping it as a default which is ID for me. Okay, and yeah, so this is a container I mean just I'm keeping it as maximum. Here you can give manual also, so where you can just you can specify the RUs. So RUs we will discuss in some in some time now. But as of now, just RUs is nothing but a request unit. So the more the RUs, so the better the Cosmos DB performance. So just keep that in mind, and based on that, you will be charged also. So just I'm keeping it a very minimal now. So as it is a demo purpose, and we will discuss the unique keys also in the further coming videos. I'll not go in detail now. So and I'll just create OK. So okay, as you see here, the minimum RU is 400. So I'm just giving 400 and enabling it. Yeah, as you can see, the default database, this is created now. And here in the item, if you see, right? if you click on the item, it is not showing anything now, right? So if I want to enter the record manually, right? So I have to click on the new item here. So once I click on the new item, so that will give this space where I can enter my record. Suppose this is my record, okay? So let me just correct it. So as you can see, this is a JSON object, right? So this is a JSON object and it should be a valid JSON here. So if it is any mistake, it will just show you like this. I mean, with underscores. As you can see here, now it is a valid JSON. There is no error here. So, and I can just go ahead and save it. So it says ID must be a string. Okay, so let me make everything as a string here. Okay, let's age be as a integer. Yeah, so since ID was a partition key, it should be mandatory as a string. So as you can observe here, after we have just added these three columns, but it has added few metadata also. Metadata is in the meaning like for this record when we have inserted, it has added few identifiers and the timestamp. So and some kind of identifier. The important thing is the timestamp here. So this is a epoch timestamp. We can convert this to normal timestamp and then see it will be the current timestamp. So as you can observe one more thing here. So the ID we have mentioned 100. But here also it is showing 100 because the partition key we have mentioned as ID. So this ID is a partition key, that's why it is coming here. Suppose we will see one more example here. So if I'm just entering like this, okay. So here if you see I don't have any ID as a partition key. So that is not mandatory. ID is not a mandatory to add. So if I just save it, it will add it. But here if you see the ID is like it has auto-generated the ID basically because it's a partition key. So it will not basically because it doesn't have any ID in the value, right? So that's the reason. And so the important thing is this always should be a JSON document. So that's why we call it as a Cosmos DB as a document DB here. And next going to the scale and settings. So if we click on scale and settings, so these are the very important settings when you are working on fine tuning the operational or production issues with respect to the performance. As you can see, there are two parameters here. You can see one is throughput and another one is request units. So I mean you can tune both of these according to your needs. And as you can see, if you are just giving auto scale here, it will just won't ask you any request units. But if you want to manually control that, so basically you can give some kind of manually you can enter whatever the capacity of request unit. The more the request unit, the cost will be more, but the performance will be better. I mean the latency of the response from the Cosmos DB will be very less. So that's the whole point. If you want to just check the capacity calculator, you can go and check here. And if you go for the settings, so in the settings there is something called as time to live, TTL we call it as. So this is again an important thing when you're talking about archival, automatic archival. So once you make it on, right, so it will ask in seconds. So whenever if you are giving in seconds, so this will always be in seconds. So if you say if you are giving 24 hours here of time, so whatever records you are entering in this kind of records you are entering into this Cosmos DB container, so that will be automatically deleted after 24 hours of entering. So that is the use of this TTL. This is the time to live. So automatically the previous records which are older than 24 hours will be continuously deleting. So in the background, so that you will not notice, that will be deleted in the background. Okay. And you can create the indexing policies also. Suppose if you want to have the better performance based on the indexing, right? So you can create an index based on the particular columns you need. So to actually have that indexes, I mean the performance, better performance, and you can have even the composite index, like combination of index, you can also have that. And yeah, so these are the main settings that we wanted to discuss here. And we can also have, you can see the stored procedures, like similar to SQL, you can have a stored procedure, and you can also have a user-defined functions. You can create a user-defined function and query that data, use that when you're querying the data. So we will see how to query the data. To query the data, we can just go to here, new SQL query, and if we just do a execute selection here, it will list all the data here. So as you can see, the response also, it is not in a tabular format, it is in a JSON format. So we have entered two records, so those two records are getting listed here. And so it is just like it will always be select star from C. C is nothing but it is a table name or the container name. We can call it as a container name, and it is a current container. If you click on this item, right, and if you come to this item and again do a select star from C, it will list the records from this particular container. As we don't have anything, it is not listing anything. So hope you understood the demo and how to navigate through the Cosmos DB account creation and also creating a container and what are the different settings and the performance fine tuning things. Yeah, thanks for watching.